Welcome to another deep dive. You know I love this stuff. We got a fascinating collection of articles and research on time travel and, well, it's always kind of blown my mind. Is it just science fiction? Or could there actually be some real science behind it?
It's a question that's fascinated people forever, really. And, we may not have a time machine just yet, but diving into the science behind time travel takes us through some of the most incredible ideas in physics.
Okay, so where do we even start with something as massive as time travel?
Einstein's a good place to start, I'd say. His theories of relativity really turned our understanding of time upside down. Before Einstein, we saw time as absolute, right? Just ticking away the same for everyone everywhere. But Einstein showed us that time is much more flexible.
Yeah, time being relative, I remember that. But it always felt very theoretical. Can you give me a real-world example? Like, how does that actually work?
Sure. Picture this. Two identical clocks. One stays put here on Earth, and the other blasts off into space on a rocket, going almost as fast as light. Einstein's special theory of relativity says the clock on that speeding rocket would actually tick slower than the one on Earth.
Wait, so the faster you go, the slower time is for you. That's crazy. Does that mean if I hopped on a super fast spaceship, I'd come back younger than everyone else?
That's exactly what time dilation suggests. And it's not just theory, we've proven it. Scientists have put atomic clocks on planes and compared them to ones on the ground. Even at those speeds, way slower than light, the clocks on the planes ticked just a tiny bit slower. It's a real measurable thing.
So time isn't this fixed thing we all experience the same way. It's almost like a river flowing at different speeds depending on how fast you're moving along.
I like that. Good analogy. And then it gets even more interesting when you bring in Einstein's general theory of relativity. That one tells us that gravity also messes with time. Stronger gravity. Time slows down.
So time moves slower where gravity is stronger. So is tying on top of Mount Everest different from time at sea level?
You got it. It's a teeny tiny difference. But yeah, time at higher altitudes with a bit less gravity actually runs a little faster than at lower altitudes.
So even how we experience time every day is subtly affected by gravity.
Yeah.
It makes you wonder what else we take for granted is actually being warped by this relativity stuff.
Exactly. And these aren't just theoretical ideas either. Think about GPS satellites. They're orbiting Earth super fast and experiencing weaker gravity. They have to adjust for those relativistic effects to make sure they can navigate accurately.
So our phones are constantly proving Einstein right whenever we use GPS. That's incredible. Okay, so Einstein's theories tell us time is relative, gravity warps it, motion warps it. But how does that actually connect to the idea of time travel?
That's where wormholes come in. Imagine a tunnel through space-time, a shortcut between two distant points. Not just space, but time, too. If we could travel through a wormhole, you could theoretically enter one end and pop out the other at a completely different time, maybe even in the past.
Wormholes, like those tunnels in the movie Interstellar, so we could actually use them to go back in time.
Well, that's the million-dollar question. Wormholes fit into Einstein's equations, but they're still very much in the realm of hypothetical physics. We haven't actually seen one directly, and even if they're out there, keeping one open and stable enough to travel through might need something called exotic matter with negative energy density.
Negative energy density. That sounds like pure science fiction. Is there even any proof that stuff actually exists?
That's the catch. We've never observed anything like exotic matter anywhere. It's an idea physicists came up with to explain how wormholes might work, but whether it exists or not is still a mystery. So for now, hopping into a wormhole and zipping back to ancient Rome is still in the realm of sci-fi. But you never know what the future might hold.
Very true. Even if wormholes are a dead end for time travel, there might be other, even crazier possibilities out there. Speaking of crazy, I think it's time we tackle quantum mechanics.
I like where your head's at. Quantum mechanics throws a whole bunch more weirdness into how we think about time. Challenges our very ideas of cause and effect. Get ready, things are about to get strange.
Can't wait. That's why I love doing these deep dives.
So we've got Einstein's relativity changing how we view time. We've even touched on wormholes. Now let's throw quantum mechanics into the mix.
Quantum mechanics. This is the part that both excites and terrifies me, to be honest. It always seems so mysterious and it just doesn't make sense.
It definitely challenges how we normally think the world works. That's also what makes it so fascinating, One of the key things about the quantum level is that things aren't so definite. You have probabilities and uncertainties instead of just fixed states.
So instead of things being like here or there, they can be in lots of states at the same time. How does that even work?
Think of a coin spinning in the air. Before it lands, it's not really heads or tails, right? It's both at the same time. That's kind of like superposition. A quantum particle can be in multiple states at once until we actually measure it.
Okay, I think I'm starting to glimpse how weird this quantum world is. But how does this tie into time travel?
Well, things in quantum mechanics like entanglement make you wonder if time really flows in a simple line. Imagine two particles linked so they instantly affect each other, even if they're miles apart. That's entanglement.
Entanglement, I've heard about that.
Yeah.
Isn't that where two particles are connected, and if you change one, the other changes instantly, no matter how far apart?
That's it. That instantaneous connection is what's so crazy about it. It seems to break our normal understanding of cause and effect, like events happening in order. It's almost as if those entangled particles are talking to each other outside of time.
Could entanglement be a way to send messages back in time then? Or even travel back ourselves?
As cool as it is, entanglement doesn't actually let us send information faster than light. And that's still considered a fundamental limit, according to Einstein. So no time-traveling messages, sorry. But it does show there might be more to time and causality than we think. Challenges that straight-line view of time and opens up some really wild possibilities.
I'm seeing why quantum mechanics is relevant to time travel now. But you mentioned even weirder implications. Tell me more.
Think back to that superposition idea, a particle being in multiple states at once. Now imagine if time itself could be in superposition, existing in multiple states or even flowing in different directions at the same time.
Hold on. Multiple directions of time. Is that even possible?
Wild, right? We haven't actually seen any evidence of it in the real world, but it's something physicists are exploring through theoretical models and simulations.
Simulations. So are scientists trying to build time machines based on these quantum ideas?
Not exactly time machines like hopping in a vehicle and going to another time. But what they're doing is using quantum systems to simulate time travel, like creating these carefully controlled quantum systems where they manipulate entanglement and superposition to mimic certain aspects of time travel.
So even if we can't physically time travel yet, we can at least explore how it might work on a fundamental level with these simulations. That's amazing.
You got it. And who knows what those explorations will uncover? Every new discovery in quantum mechanics seems to open up even more bizarre possibilities about time and reality.
Okay, so we talked about Einstein's relativity, the hypothetical wormholes, and now this mind-bending quantum mechanics. They all kind of suggest that time travel could be more than just fantasy. But if we ever did figure out how to travel through time, wouldn't that lead to tons of paradoxes and ethical problems?
Absolutely. Time travel brings up a whole bunch of philosophical and ethical questions we'd need to think about really carefully. What if going back in time accidentally stopped you from being born? Or someone used it for bad reasons, changed history for themselves? Not easy questions.
That's the classic grandfather paradox. I've always wondered about that. What happens if you go back and stop your grandfather from meeting your grandmother? Would you just disappear?
The grandfather paradox is a great thought experiment. Really shows the potential for contradictions if you mess with time travel. One idea is the Novikov self-consistency principle. It basically says any actions a time traveler takes were always part of history. You couldn't change the past because your actions in the past are already woven into how things happen.
So it's like the past is unchangeable, even if we could time travel.
That's one way to see it. Of course, that brings up questions about free will and if our choices even matter if the past is set. But the Novikov principle is a pretty fascinating way to think about how time travel might work without those paradoxes.
It's also mind-blowing. It's like every time you peel back a layer of this time travel onion, you find even more complicated questions underneath.
And that's what makes it so great. Time travel isn't just about building a machine to visit the past or future. It's about pushing our understanding of reality and facing some of the biggest mysteries of the universe. It makes us rethink time, causality, even what it means to exist.
Well said. I think that's a perfect spot to wrap up our deep dive into the science of time travel. Wow, what a deep dive this has been. We went from Einstein's wild theories of relativity to the idea of wormholes and then that crazy world of quantum mechanics.
Yeah.
It's amazing to think that time travel, something we usually just think of as sci-fi, might actually have some basis in real science.
It really is. Exploring time travel makes us face some really deep questions about what reality even is. Even if we never actually build a time machine, the journey itself helps us understand the universe and our place in it.
Totally agree. It's like trying to figure out how time travel might work gives us a better understanding of how time actually does work.
Which leads me to my next thought. Where do we go from here? What are the next steps in figuring out these mysteries of time?
Well, one big thing is to keep pushing the limits of what we know scientifically. There's still a ton we don't know about the universe, especially when you try to combine quantum mechanics and general relativity.
Right. Those two big theories in physics, they seem to describe the universe in totally different ways, and scientists are still trying to find a way to put them together into one big theory.
Exactly. And that search for a theory of everything, it could unlock even more about time and maybe even show us new ways to manipulate it.
And I bet those quantum simulations we talked about will be a big part of that.
Absolutely. When we simulate time travel scenarios using quantum systems, we can test out different theories and get a better grasp on those paradoxes and what might happen if we could actually do it. It's like we're running experiments in a virtual time machine. That's such a cool way to think about it. So even if a real time machine is still a long way off, we're already starting to understand time itself on a deeper level through these simulations.
Exactly. And on top of all the theoretical stuff, there's the search for weird phenomena out in the real universe. Things like wormholes, if they're even real, would be super hard to find, but not impossible.
So there's still a chance we might bump into a naturally occurring wormhole someday. Now, that would change everything.
It would be huge. It would rewrite our understanding of the cosmos. And even if we never find one, looking for them could lead to discoveries we never expected that make us understand the universe even better.
It's so exciting to think about what the future holds. Theoretical breakthroughs, experimental discoveries. Time is an ongoing journey of exploration. Who knows what incredible stuff we might find just around the corner in space-time.
Well said. And to everyone listening, hold on to that sense of wonder. Keep asking questions, exploring, pushing those boundaries of what we think is possible. The universe is full of mysteries, and maybe someday, the secrets of time travel will be one of them.
That's a perfect way to wrap things up. Thanks so much for taking us on this incredible deep dive into the science of time travel. You've given us a lot to think about. I know I'm feeling even more curious about the universe and ready to learn more. And to all you listeners out there, keep those minds curious, those imaginations going. And until next time, happy time traveling.